Next key term is a perfect square. A perfect square is a whole number multiplied by itself 2 times. So if we had 1 squared, well, 1 squared means 1 times 1, which is 1. 2 squared means 2 times 2, which is 4. 3 squared is 3 times 3, which is 9. So when you hear the term perfect square, think of a square. If you had a square and of course all the sides of the square are the same, if you had a square with sides of 6, how would you find the area of the square? Well, you would do this side 6 times this side 6, and 6 times 6, or 6 squared, would be 36. We are going to memorize the first 20 perfect squares. Now, you should have the first 12 already memorized, like 12 times 12, or 12 squared, which would be 144. We're going to memorize all the way up to 20 squared. 20 squared would be 400. Square root. A square root is when you have a number that is multiplied by itself to get the number inside the root symbol. So this symbol right here can be read as a radical symbol, a square root symbol, or just a root symbol. If we had something like square root of 25, you should think to yourself, well, what whole number times itself would give me 25? Well, you should be thinking 5, right? Because 5 times 5 is 25. The square root is the inverse operation of a square, right? So if we already knew the area of the square, if the area of the square was 36, and we wanted to know the side lengths, we would take the square root, right? The square root of 36 would be 6, and that would give us the length of the sides of the square. There are 2 square roots for every positive number, okay? There is a positive solution and a negative solution. And sometimes we use this symbol right here. It's like a plus and a minus sign, a plus sign over a minus sign, and we read this as plus or minus. So an example, if we had the equation x squared equals 16 and we wanted to solve for x, we need to get x by itself, or undo this square, and the operation that undoes a square is the square root. So let's take the square root of the left side, and of course I must also do that on the right side. So the square root of x squared, the square root and the square would cancel each other out. I would just be left with x equals, then I would have either positive or negative square root of 16. Right? So what number multiplied by itself would give me 16? You should say 4, right? So x is plus or minus, positive or negative 4. And the reason this is true is because if you take 4 and square it, like if we had 4 times 4, of course we know that's 16. But the same thing is true with a negative number, right? You could have negative 4 times negative 4. Well, that is still 16, right? So that's why we have 2 solutions, one positive and one negative. You can also, if we had something like x squared equals 36 over 49, we're taking the square root of a fraction. In this case, I would do the same thing as far as undoing the square with the square root. I would square root both sides. The square and the square root cancel. You get x equals. This square root would apply to both the numerator and the denominator. So we're essentially taking the square root of 36 on top and the square root of 49 on bottom. And of course I have a positive and a negative solution. And so x is equal to positive or negative. What's the square root of 36? That would be 6, right? And on the bottom, square root of 49 would be 7. So my solution here would be positive 6/7 or negative 6/7. If we want the principal square root, the principal square root simply means the non-negative square root, or the positive square root. You can remember this because principal starts with p and positive starts with p. So if we just see this, something like square root 25, that just means we want the positive square root of 25. So what number multiplied by itself would give you 25? That would be 5. If you were to see something like this, plus or minus the square root of 49, well, you just have plus or minus and then whatever the square root of 49 is. The square root of 49 would be 7. So you would have positive 7 or negative 7. Perfect cube. A perfect cube is the cube of a whole number. We have a whole number multiplied by itself 3 times. So we could have 1 cubed. That's 1 times 1 times 1, which is 1. 2 cubed, which is 2 times 2 times 2, which is 8. 3 cubed, 3 times 3 times 3, which is 27. Just like we take the perfect square, think of a square. Whenever you take a perfect cube, think of a cube. If you were to find the volume of a cube, if you had a cube with side lengths of 2, right, you would multiply 2 times 2 times 2, and that would give you the volume of a cube. We're going to memorize the first 10 perfect cubes. Last key term here is a cube root. The cube root symbol looks like the square root symbol, except it has a little 3 right there in the notch. A cube root is when we have a number multiplied by itself 3 times to get the number inside the cube root symbol. And just like the square root is the inverse of a square, the cube root is the inverse of a cube. So something like this, the cube root of 1. So I would ask myself, what whole number multiplied by itself 3 times would give me 1? And that would be 1, right? The cube root of 8. What number multiplied by itself 3 times gives me 8? Well, that would be 2, right? 2 times 2 times 2. That gives me 8. Now, what's different about a cube root is that you can take the cube root of a negative number. Like, what number multiplied by itself would give you negative 8? Well, that would be negative 2. If you take negative 2 times negative 2 times negative 2, you get negative 8. And so we said that for a square root, there are 2 solutions. There's 2 square roots for every positive number. For a cube root, there's only 1. There's exactly 1 solution. There's actually exactly 1 cube root for every number.